Hello everyone and welcome to the Reviews Company webinars. My name is Elena Gallego and I'll be hosting today's webinar. We have with us Borja Lopez, Rich Authoring Tool Architect, and Dr. Eugenio Parra, Quality Metrics Architect. They will introduce us the concepts and process needed to ensure requirements quality along the supply chain, based on the new version of the Reviews Company tools, the KCSE V18. Let me introduce you the invited presenters a little bit more in detail. Borja is software developer and architect at the Reviews Company, and specifically, he is the main architect of the Rich Authoring tool and the main developer of the technology for knowledge reuse. With several years of experience, he is expert in the process to index and retrieve information based on semantic approaches. Eugenio is software developer and architect at the Reviews Company, and he is the main architect of the quality metrics implemented in the System Quality Analyzer tool. Eugenio got his PhD and is still researching on the topic about new approaches for quality analysis based on artificial intelligence techniques in combination with semantic approaches. The webinar will last for 1 hour, and during the last 15 minutes, the presenters will answer all the questions you may have. Thank you very much for your participation, and we hope it will be of interest to you. Thank you very much also to Borja and Eugenio for the presentation, and let's start then with the requirements quality along the supply chain webinar.
Thank you very much, Elena. So my name is Borja, and today's topic is about how we are performing the quality assessment along the supply chain. But first of all, we'll talk first a little bit about our company, TRC. After that, we'll introduce a little bit the concepts of requirements quality in order to deal with supply chain. We'll talk about quality certificates, which is the automation tool that we have implemented in our tool suite in order to deal with this. And finally, we'll have some demonstrations. We'll show you a small video to show the interaction between the different roles in the quality chain, and then we'll go for questions and answers. So, first of all, TRC. We are a small company based on Madrid, Spain, but the majority of our customers are all around the world. Historically, we had our first customers in Europe, but nowadays we continue growing all around the world. For instance, in the US, Asia, etc. And we are growing not only in terms of number of customers, but also by having local partners in different locations all around the world. Since our technology focuses on detecting defects in specifications, among other things, we are focusing on safety critical systems. So for this reason, our main markets are aerospace and defense, automotive, railway and energy, but also some others such as legal and healthcare. So before going deeper, a brief introduction about our solution in the market called KCSE Knowledge Centric Systems Engineering Suite V18, which has been recently released last December 2017, and it includes huge improvements from the last version we had in the market called V15. So first of all, we have SQA in yellow, which its main goal is to configure the metric, to let the user configure the metric and perform a quality assessment on specifications, find defects, generate reports, and so on. Then we have the RAT, the Rich Authoring tool in green, which is able to author new requirements by taking into consideration the quality rules that have been defined in SQA, doing all these things in real time. Then we have System Knowledge Manager in blue, which is responsible for managing all the knowledge that we put into our ontologies to make the whole suite smarter by having vocabularies, taxonomies, semantic clusters, breakdown structures, and so on. So all these things together make possible to have more accuracy, not only in regards to providing quality assessment, but also for other duties inside our technology, for instance, a search engine to find overlapping requirements. And finally, we have the System Interoperability Manager, which is composed by several plugins. And for instance, out of the box, it provides the R plus and T plus plugins in order to deal with reasoning and traceability. So today we'll focus a little bit on the system quality analyzer to talk about quality assessment along the supply chain. So first of all, when we are dealing with complex products, we commonly in the market, we don't see companies that are developing or producing the whole system from, let's say, from the conceptualization to the deployment. So we have different companies that are building the subsystem, then they are integrated into the whole product, so that we have what is called the supply chain. On this chain, we have different layers: the OEM, which is the main contractor, the main producer, manufacturer, and then we have several layers for suppliers: the tier 1, the prime suppliers. Then we have more suppliers in the tier 2. So it's important to, let's say, to close the gap between all of them in order to have a better communication and all the system and the success on the projects. So it's important that we may have some suppliers that are fulfilling the requirements that the OEM needs, but they couldn't be the proper suppliers for this OEM. So could be because of several reasons. So the good practices say in order to have good specifications or to improve the specifications we have, it's very important to measure. So in our approach, by measuring the 3 C's, CCC for correctness, completeness, and consistency, we are able to configure the metrics that, for instance, are defined in the INCOSE guide for writing requirements in an automated tool, which is able to measure not only correctness for individual requirements, analyzing the structure of the requirements to detect misspelling or ambiguity, conditionals, all that kind of things, but also consistency or completeness by having into account a whole set of requirements or several requirements documents, for instance, to avoid duplicated requirements, inconsistent properties, and all that stuff. So a single company can apply this technology to their documents, but when we have different companies involved in a product life cycle, it can be more difficult to have all of this integrated. So we have developed what is called a quality certificate that basically integrates the quality assurance process between the whole supply chain. So the OEM is able to define quality rules, quality metrics implemented in a quality certificate, which is going to be deployed by the different suppliers that they have, so that the OEM ensures that the suppliers are fulfilling the metrics that they force. So from the supplier's point of view, it's possible to generate periodic reports of the state of the quality in every single moment, so that the OEM can keep track of the quality for the whole product life cycle. So let's talk a little bit about what is the quality certificate. Then at the bottom of the screen we have a screenshot of Systems Quality Analyzer, which is the tool that manages all this kind of stuff related to metrics, quality certificates. We'll see deeper on the video, and then we'll show you a little bit also the tools live. So basically, the quality certificate is a self-contained package where we put all the metrics together, and then this package is possible to distribute to the different suppliers to integrate in their processes and to have quality, to produce quality assessment on the subsystems developed by the suppliers. So it's just a matter of defining the metrics in SQA from the OEM point of view, and then just pushing a button to generate this quality certificate and send this by email to the suppliers. Then the supplier just integrates the quality certificate, and then all the metrics in there are available to be used for quality purposes. Once the quality certificates are inside of the supplier's process, let's say, it's possible to perform analysis. For instance, we have a screenshot here on the left showing the current quality of a system developed by a supplier, and then it's possible to create snapshots, let's say screenshots, or how to say, of these quality reports in order to send this information to the OEM. So on the right, the OEM receives several quality snapshots, so it's possible to see how the quality evolves during the product life cycle. So to sum up in a big picture, the process, one of the possible processes could be having the OEM on the left-hand side. They defined the metrics to be applied by the suppliers. So the first action is just deploying, sending the quality certificate to the different suppliers so that they can work on their own to generate their requirements, their models, test cases, and so on. And once they are doing the work, they are able to send quality snapshots to the OEM to the left, so that the OEM is able to control the quality evolution and to decide if the quality is good enough or if they need to have more iterations in order to improve their requirements. And this can be an iterative process. So just as a mark, suppliers, when they receive the metrics, they are for sure using SQA. SQA allows the user to fully customize the metrics the way they need. So for sure we could wonder if the suppliers are able to change the metrics the way they need. So to answer this question, it's fully up to the OEM definition of their quality certificate. So we allow the generator of the quality certificate to define 3 levels of, let's say, protection level. The first one, quality certificate, will be open source. It means that the supplier is able to change the metrics the way they want. Of course, use the quality certificate and so on. The second level, which is a little bit more restrictive, the quality certificate will be available to be used by the supplier, but it's not possible to change the definition of the metrics. When I say to change the metrics, it mainly means to change the configuration. If we have a completeness metric that basically checks the coverage of warning signals, for instance, it will check the coverage of, for instance, 100 terms. So if I am able to change the configuration of the metric, I can, from that 100 terms, I can remove half of the terms, so that, let's say, the metric is less restrictive. So getting back to the levels, the last one is fully locked black box quality certificate, which is only available for usage, but it's not possible to see neither the configuration of the metrics nor to change that configuration. So now let's see a small video where me, together with my colleague Eugenio, will have different roles. I'll be the OEM, just to generate some metrics and to send him a quality certificate. Then the second part, Eugenio.
Okay, thank you, Borja. Yes, in the demo, I'm going to represent the supplier. The supplier received the quality certificate by the OEM. Import the quality certificate, so I import the metric, the metric configuration, the ontology into my SQA, and I will analyze the quality of the specification based off this metric, and generate periodically quality snapshot, and I'm going to send this snapshot to the OEM in order to control the evolution of the specification.
Thank you. And once that's done, the third part, again, I'm the OEM. I received the quality snapshots that Eugenio did while developing the braking system he's going to show. And I can control how the quality evolved during this development. So let's go for it. Here we are. So the first thing is just to define some metrics by using SQA. So we have here one configuration called ISO 26262, which mainly contains some of the metrics defined on the ISO standard. So we have here some correctness metrics, as you can see, to avoid conditionals, to avoid passive voices, incorrect spelling, all that kind of stuff related to correctness. But we also have some metrics for completeness and consistency. So in particular, this metric for completeness is just assuring, just pointing that some warning signals must to be specified on the requirements. So once I have the metrics ready, I'm just generating this quality certificate, which I'll send to Eugenio to start building this subsystem. So I'll define the level will be read-only, and then I just put here a name so that a single file will be generated, and I'm able to send this file to him by email. We're just again generating the file. This file contains not only the metrics, but all the stuff that we need inside of the metrics, which is indeed the ontology that we use behind the scenes, the terms, the semantic clusters, the breakdown structures, patterns, properties, all the things that the metrics are using here, all the dependencies are automatically imported in the quality certificate to just plug and play on the supplier and be ready to use. So now it comes the second part, which is going to be led by Eugenio. So for you.
Okay, thank you, Borja. So as I said, I represent the supplier, and I received the quality certificate of the OEM, and I'm going to import this quality certificate in the specification. In this case, I represent the developer that I'm developing the brake system, and I connect to my specification by exec file that contain the requirements. I'm connected in this demo in the safety requirement, and this is the first draft of my specification that only contain five requirements, and I'm going to import the quality certificate that the OEM sent me. This is the file that the OEM sent me by email. And when I import the quality certificate, I import in my SQA the ontology and the configuration of the metric that the OEM needs or decide that is necessary to assure the quality of the specification. The restriction that the OEM decide is the read only, so I cannot modify the configuration of the metric. Now it's necessary to import to assign in the module the set of quality metrics. So now this module is configured with the metric. Now I'm going to assess the quality of the specification. And in this case, I have 4 requirements with high quality and 1 requirements with low quality related to the correctness metric. And in completeness metric, I have a low ratio, and this is because in my specification I don't have any requirement that that cover the warning signal that the OEM decide that I have to cover. So this is the scoreboard that represent the quality information graphically, the quality information of the specification. And with this quality, current quality, I'm going to save all the complete quality information, the SQA, in a snapshot, and I'm going to send this snapshot by email to the OEM. So now I'm going to improve the quality related to correctness metrics, and I modify the requirement. In this case, it's a very simple mistake. I'm going to select the proper and correct word. Okay, and after that, I have a high quality in related to the correctness metric. So now I want to assess the quality for the whole specification. After that, we can see that we have a high quality related to the correctness metric, but we continue have a low ratio of quality related to completeness. So with this improvement, I generate the quality snapshot and send this evolution to the OEM. Remember that with this snapshot, I send all complete information of the specification, and we are going to view with more detail what is the composition of the snapshot after the video demo. And now, sometimes later, we are complete the specification by modifying different requirements and adding new ones, and we are assess the quality with the same metrics that the OEM send us. And now, related to the correctness, the completeness quality, we have high quality, and this is because now the specification cover the warning signal that needs the OEM to include in the specification. So this is the current quality scoreboard. Now we have high quality in the completeness metric, and I send the new state of the quality to the OEM, creating a snapshot again. This creation of the snapshots is periodically in order to the OEM taking into account the evolution of the specification. And now Borja continue with the video demo that represent again the OEM.
Thank you very much, Eugenio. So the last part of the video is once the supplier has finished the subsystem, I've been receiving periodically quality snapshots during the development. So I've imported all of them in a quality viewer. We have right here. So instead of having hundreds and hundreds of rows of requirements with stars, which is very nice to see, but indeed it's not straightforward to see how it evolved and to have everything controlled in a whole view. We have this information, which is basically the scoreboard or on different point of views of how the quality evolved during the whole process. So we can see how the green area increases. It means that the requirements with good quality increased with the pass of the time. The number of path requirements at the beginning was higher than 50%, and then they decrease until 5% or something like that. And we can also see how the completeness of the specification increases. So we see that at the beginning, none of the completeness metrics were fulfilled, but at the end of the project, we only had one, the one that we showed. But at the end of the process, this metric was fulfilled, so we got 100% completeness. We'll show you a little bit these drawings in detail after this demo. So just a brief summary. Once we have defined the metrics as an OEM, we can generate the quality certificate to send to the suppliers in order to produce quality assessment in their own specifications, and then we can control the evolution of the quality of every single supplier that we had. So this is the way we have implemented in SQA in order to control the requirements quality assessment of the whole, let's say, subsystems along the supply chain. So now, just let us finish this demonstration with just by showing you some things that are not explained in the video. So, for instance, just let me open SQA. Let's see first the quality report that we had. So I open the quality evolution view. So on this screen, we have in a first sight how the quality evolved during the project. But it's not only this, because we are able to select a specific point in time. Let me double click on it, so that we can see more details about how was the quality in that specific time. So we can see that at the beginning we had no requirements in green. It means that most of them were medium quality in yellow, and some others, 25%, around 29, were they had bad quality. Then for completeness, I guess we didn't have any completeness metrics, so we didn't have any information. Since the project was evolving, I can double click here again, and I see that the number of requirements, first I see that the number of requirements increased by themselves, but we can also see that the number of yellow requirements decreased, and then we started to produce some quality requirements in green. I guess, Eugenio, you were using the authoring tool to create new requirements and to have good quality from the beginning. We will see. So that we can see how the project evolved. And finally, on the last stage of the project, we have around 67% of requirements in green, but we still had 33% of requirements in red. So then it's up to me, let's say to the OEM, to decide, if this percentage of green requirements is okay or is not okay. We could decide to force, let's say, the supplier to perform another review of the requirements in order to better improve by using SQA the requirement, the quality that they have. Not only at this point we can see let's say the percentages, we can also see some details about the requirements, in this case 45, that the supplier had in this time, so that we can see a little bit about how they were composed. We can also see more information, more detailed information regarding correctness, so it's possible to see the worst metric that we have. Let me check. Well, I will sort here. It's the same. Wow. Yeah. So the worst metric, let's say, which was provoking most of the problems, was that we were not using imperative. So I guess we could be using conditional verbs and all that stuff. On the contrary, we had the best metrics, let's say. For instance, we were not using any passive voids, no impressive quantifiers, and so on and so forth. So regarding completeness, we also have some completeness and consistency metrics in this example. So we can see that we had some of the metrics with no calculation, but we also have some completeness metrics. In this case, we were covering all the terms coming from this PBS that were defined on the metric, but then we have some models in order to perform, completeness between the models and the requirements, so they were not fully complete. For sure, it's possible to create individual reports for every single metric or reports for the whole set of metrics. The same for consistency. We had some problems over here. We had overlapping requirements. Some properties coming from the PBS were not complete. Were complete because we saw it in the completeness tab, but they were not consistent. So maybe in some requirements we were talking about that the maximum weight of the wind would be, I don't know, 100 kilo, and then a requirement was talking about 120 kilo, for instance. So I think that's all from the quality scoreboard. Another interesting stuff is that we saw in the video that Eugenio was at the beginning, he only had 5 requirements. Then in an internal review iteration, they had 10 requirements or something like that. And at the end of the project, they have some 45 requirements. So we could use the rich authoring tool to create those requirements. So if you want to, maybe Eugenio, just to clarify the roles, you could tell us something about how you use the authoring tool to create requirements, just to create some requirements here and so on.
Okay. Thank you, Borja. This is the requirement authority tool that is the son of Borja. Okay, and with this tool we can create new requirements based on the pattern that we defined in the knowledge manager in our ontology, and this is the editor to create the data to create the requirements. So this. Okay, and now I'm going to create a very simple requirements. So let me. Okay, let me. I want to write the requirement. So in this case, the tool author the next step that we have to use related to completeness and related to syntactic and semantic information that the pattern contain. In this case, we are using a property, a physical property of the different system element, in this case component, and with this we follow the pattern for the semantic and syntactic information of the pattern. We can create a new requirement based on this information. When I'm going to decide the measurement unit, and now we have a requirement that matches with the pattern. So related to syntactic and semantic view, this requirement is correct. So and with this, when the requirement matches the pattern, we have a green square. And now I'm going to now I introduce a sort in, because with this correctness metric reveals that we have problems in the requirement. So as you see, you have a assessment of the quality on fly when you write the requirement based on this pattern. This is the power of this tool. Now we have a correct requirement with green square and green squared in the current quality. So this requirement is correct, and we decide save this requirement in our specification. So it's possible to generate and modify requirements using the tool, but it's possible to use this tool, the plugin inside the door. For example, you use the doors, the plugin of doors. You can create and modify requirements inside the tool, inside the doors tool, and with the power of the authoring, with patterns and assess the quality. So this, for example, I'm modified the one requirement. I add new requirements, and I save this requirement in the specification. So maybe we can pass to other tool. In this case, we are going to show the knowledge manager. The knowledge manager, isn't it, Borja? Okay. So thank you very much.
Thank you, Eugenio. So when we were using the rich authoring tool, we were connecting to a spreadsheet requirements stored in Excel. So we are changing when we are saving the requirements there, we are changing the content of the requirements directly in the Excel sheet. Okay. So last part. So if you remember the picture of the KCSE suite, we had a tool called System Knowledge Manager, which is basically responsible for connecting, to the ontology, for managing the terminology, relationships between terms, PBS, breakdown structures, patterns, formalizations, and all that stuff that they are used then later on for quality assessment, retrieval purposes, and so on. So here we have two ways of working with Knowledge Manager. We can put all the information here. So we see that we have more than 3,000 terms. We can create terms manually. We can import them from other sources, or we can use quality certificates and libraries in order to build, let's say, small bricks of information, specialized information, for instance, terminology for safety with patterns and so on, terminology for procurement and so on. And then we are able to import the libraries into, let's say, a master ontology that will use all of this information. So just let me close it because I connected to an ontology that I didn't want to show you. So we have, just let me connect to this one and go here to extensibility. And we have something called my imported libraries. So the notion of library is very similar to quality certificate. Indeed, it's using the same technology or very similar technology. So it means that I'm connecting to a database which has 7 libraries integrated inside of them. So every library has been developed by the owners. So once that ontologies are ready, the library is generated out of the ontology, the same as the quality certificate, so that it's possible to send me this library indeed, so I can import it in my system and use it. So if I come to the terminology, I see that from the initial 3,000 terms, 3,500 terms, now we have almost 15,000 terms. So most of them are coming from the different libraries that I imported in the system, in my ontology. So, for instance, we have some views here on the PBS. For instance, this view is coming from the statement of work library, containing here the terminology, the relationships between terms, and so on. We also got some semantic clusters in order to group the terms there. These semantic clusters can be used then for patterns or for completeness metrics, so that we can check the coverage of this terminology in my specification according to the different levels. And very important feature in this version, we provide configuration management for the ontology and also for the metrics. So I create an ontology baseline before importing the different libraries. So if I perform a quick operation to see the differences between the current ontology, the current information that I have in the ontology, and the information I had before importing all these libraries, we can see that we have imported more than 14,000 terms. We have also some semantic clusters here. For sure, in the system conceptual model, we added a lot of relationships between terms. We have new patterns and pattern groups, some changes on natural language processing, so that we have quite a lot of new information in this ontology just by importing 7 different libraries. Yes, and I think that's all from our side here. So let me back to the slide. So if this is the end of the presentation, so Elena, if we have any question.
Thank you very much, Eugenio and Borja. It's been very interesting to see a different approach that can help contractors and their providers to evolve requirements and their design quality priorities, but also ensuring the requirements compliance and the whole life cycle of the specification document. This automation of the process also seems to be very useful to avoid issues derived from ambiguities, incompleteness, or inconsistencies of the requirements documents, and thereby reducing the changes to jeopardize the project. Before going into the questions, another interesting aspect from your presentation to me has been to see how you close the whole process when using the KCSE tools. You first develop in Knowledge Manager your ontology with terminology, breakdown structures, patterns, and other elements. And then with the System Quality Analyzer, you configure a set of quality rules, in this case according to the OEM quality priorities, to finally combine both knowledge and quality into one single file, a certificate or quality library, which help the requirements authors to write good new requirements or improve the existing ones with the rich authoring tool, having as a result a complete process covering all the main activities to ensure high quality specifications with the support of KCSE tools for all the stages. And now we are pleased to listen to the participants' opinions. So if anyone has comments or questions, you can send them through the chat box to the reviewers company, and we can collect them to answer them. There's one question. You've been talking about requirements quality during the webinar, but I've been told about the different applications of the tools to models. Does this approach of quality certificates and evolution apply to other kind of elements besides requirements? Thank you.
Thank you. Yes, we talk about requirements, but for sure in V18, one of the major developments have been not only connecting to requirement sources. Just as a reminder, we don't store the requirements in our systems. We just connect to the requirement sources such as stores or Excel sheet or RecIF. We have this information, we represent it in our schema, and then we provide the assessment out of this. But not only for requirements, but also for other kind of what we call at the end of the day work products, in order to make a more generic concept for them. So in version 18th, we have I think I could show you one slide. Just let me check. It's there. Just 1 minute. Is this one? This one. So here, in the middle of the screen is the whole suite. Okay, not only the SIM as the image shows, but the whole suite. So we are able to connect not only for the typical requirement sources that we were connecting in V15, but also we've implemented connectors to modeling tools such as Magic Draw, SysML, and Papyrus, IBM Rhapsody, and some others. Also for simulation tools, Simulink, Modelica, and so on. But also we have opened the door for any kind of connector that is implementing OSLC. We are working as both roles, provider and consumer of OSLC KM. So we are able to connect, let's say, to represent any kind of standard, any kind of schema into our own in order to provide this assessment. So it's also very important that we also develop the connectors and native plugins on top of Microsoft Word and Excel. So the interface of the authoring tool works very much smoother than in version 15. I can show you. Just let me open SQA. The main window of SQA shows some of the connections that I already have to different sources. We can see some Excel, RecIF, IBM Doors, and some others. So we can create a connection to the typical ones, but we also have here the OSLC KM we were talking about in this slide, last slide I show you. So we can create a connection to any kind of connectors. If I select SysML, for instance, for modeling, we could use models coming from Rhapsody, Papyrus, Magic Draw, or other, which is not included into this suite, but we allow the user to create a transformation schema based on XSLT schemas to be able to transform everything. So the answer is yes, we are not connecting just to requirement sources, but also to a wide range of different connectors.
Thank you very much, Borja. We have another question, which is when you are managing a whole project, you might have several quality priorities that you must follow. Is it possible to manage several quality certificates in the same project? Thank you.
Okay, thank you, Elena. This is a very good question because it is usual and normally this process, and of course we can use different quality certificates. And in the first step of the project is normally to use a set of correctness metric, and in order to analyze the correct quality of my specification. And when you have enough set of requirements, you is normally introduce completeness metric and consistency metric, because this kind of metric analyze the quality for the whole specification, not only for individual requirements. So in the evolution of the project, the OEM is usually decide the different set of metrics to analyze the quality of the metric. So yes, the answer is yes, and it's possible, and is the frequent to use this process in the evolution of the specification.
Okay, thank you very much, Eugenio. And I think we have the last question. That is, what if the quality of the supplier's requirements is lower than expected? Could you do something with that?
Yes, sure. Just let me back to the example that we had in SQA. Let me close the viewer for the different snapshots we got from the supplier. So up to this point, if we suppose that let's say the development of the subsystem is already finished, we see that At this moment, the quality, we have near 30% of the requirements with low quality. We can have a look and decide either these requirements are okay to me as an OEM, where I forced the rules to be fulfilled by this supplier, if these requirements are okay to my system, or if I need more requirements to specify whatever kind of completeness metrics which are not covered. I could decide that for sure these metrics need to be covered, or even if we have some consistency information that is not acceptable for us, let's say. So it's up to the OEM to decide whether accepting this quality or not. So there is not a rule to say if higher than 8, then the quality is okay. If lower, then it's not okay. It's a little bit flexible. So each one can decide either accepting it or not. But for sure, SQA allows, it's not, let's say, God. So it allows you to do whatever you want, having into account the rules. It's not forcing you to, if you are not fulfilling it, you cannot deploy. So you can decide. Okay.
Thank you very much. Thank you very much again to all the participants, and thank you to the presenters, Eugenio and Borja. Should you have any further question or want to have more information, don't hesitate to contact us by email at contact@reuscompany.com or in our website, reuscompany.com. Thank you, and see you on our next webinar about managing the quality tools ecosystem, the doors, Rhapsody, Simulink, and Modelica, that will take place on February the 20th and 22nd. Thank you, and see you next time.
Thank you.
Thank you very much. Bye-bye.
Bye.